Hello and welcome. We're here. We're going to be talking about Node. We're going to be talking about building web applications with Node. My name is Casey Bisson. I am Director of Product Management at Joyent, where we operate a public cloud. We are unique among public clouds in offering the software that runs our public cloud for you to download. It's totally open source. You can download it, use it for free to run your own private clouds. You can get support from us to run in our in your own private cloud, or of course in our public cloud. We have locations worldwide, and you may know us from our sponsorship of Node and incubation of Node. And today I really want to talk about that and actually how we are building Node applications. So with me, I've got a great team who's been building that, and introduce the team, the great people who are going to be talking with us about how we're doing this. And Wyatt, why don't you start?
Sure. My name is Wyatt Preul. I'm a product engineer at Joyent, working with Casey and all these other great folks. I've been doing Node pretty much since the beginning and been very involved in a few different projects. Most notably is hapi.js. And with Hapi, I've had experience developing different applications, both just API and then web applications. Yeah,
awesome. And I bet we're going to be hearing more about Hapi as we go. Yeah. All righty. Well, yeah, let's keep the ball rolling.
So my name's Colin Ihrig. I am a product engineer here at Joyent. I work with Wyatt, Casey, David, and Lloyd. Prior to, and actually while I've been at Joyent, I do a lot of work around Node Core, libuv, and also Hapi. That's where I met Wyatt. Yeah, I'm looking forward to talking to you guys today about how we're building Node applications using modern software.
Awesome. And Colin, you're actually on a handful of Node core committees. Is that right?
Yeah. So I'm on the technical steering committee and then the security working group.
Awesome. I'd love to hear more about what happens, what goes on in those. All righty. Well, great to have you.
Thanks.
Hey, I'm David Neal, and I've been working with Node.js for about 4 years, and built some APIs, also done a lot of command line applications and Electron desktop applications. I do like the JavaScripts, and I'm entirely made of bacon.
Is there a chance I've seen you before at a conference or event?
I do, yeah, perhaps so. I've speak at a lot of conferences all over.
Yeah. So we're excited to have you here, and yeah, great. All righty.
My name is Lloyd Benson. Hello. I do a lot of the making the magic of Node.js, and I help a lot on the operations side. So I can do the programming and the JavaScript, but I try to make the magic and dreams into reality. So I spend a lot of my time kind of operationalizing things, getting it all scripted, doing infrastructure as code, the DevOps stuff, all those kind of buzzwords. That's kind of the magic that I tend to provide. So this is kind of an exciting opportunity for me because we're doing cloud and open source stuff. So what's not to like?
Fantastic. And what brought us together for this conversation is actually work that we've been doing on a project to replace a web application at the core of what people see at Joyent. Now, it's awkward because I don't want to demo the web application. We're not ready for that yet. But what we've been doing is taking this legacy, somewhat monolithic web application and replacing it with a modern implementation. And I want to ask around the room, are there things, are there specific things that you had in mind as you were looking at this opportunity to not just refactor, but to reinvent the web application and build it as a truly modern application? Anything specific come to mind?
I can talk a little bit about the operation side. One thing that I kind of liked about this new opportunity is to kind of have things in a per data center view. So that's been kind of interesting, as opposed to just having like one thing in, you know, that kind of a single point of failure problem. So it's kind of nice to have like an entity that lives in the data center, so you don't have kind of cross data center communication kind of issues or network issues. It gives it a little bit more reliability.
Cool. I'm gonna ask a question to try and trigger that again. But one of the things that I heard from you, actually, Lloyd, you've been focusing on the operations of this, and you've certainly had an opportunity to reinvent the operations. And I think you've been looking at this from a perspective of isolating everything by data center. So you have isolated fault domains. I think this is a pretty good insulation against cascading failures between data centers. Can you say any more about that?
That and also, like, when you're doing things like deployments, for example, right? It's nice to be within your same data center, so that you can, you know, if you don't have like, oh, I had a network problem and now I can't actually deploy things to this data center. So, and things are obviously faster because they're all in the same network, so to speak. So there's that kind of thing. Monitoring also is nice to have kind of centralized in that same scenario, so you can tell if it's a slowness due to outside of parameters or something within its own network. So it just kind of gives it a little bit more reliability. And should you have an issue, you're obviously contained to that one data center as well.
Yeah, fantastic. I want to bring it back to away from the operational side, and I want to actually press Wyatt. I think I know Wyatt, you've been really deeply involved with Hapi, and I think that influenced how you look at the problem that we're facing. Do you want to walk us through what you saw in terms of thinking through the implementation and how you wanted to shape that?
Yeah, so I would say first off that the timing of this project was perfect because it lined up with the release of Hapi 17, which shifted everything away from the callback and old promises style that Node is, like anybody who's been doing Node for a while is very familiar with callbacks or just the old promises style. So Hapi 17 is all async await. And so we were able to embrace that new architectural programming style with this project. And I think that's benefited us quite a bit. Like our code, I feel like, is much easier to read and reason about. There's actually less code as a result of moving away from all the callbacks. And it's actually running pretty quickly. And so far, we haven't found any memory leaks, which is something that I've run into in the past whenever I was using older versions of Node or older versions of Hapi. So we've definitely seen some benefits there.
Wow.
And so,
you know, I'm realizing that we probably want to take a moment and be clear about what Hapi is and share a little bit of that.
Yeah, that's a good point. So Hapi is a web application framework for Node. It came about after Express, and the reason mainly is because Express had a lot of shortcomings, and it didn't bring enough to the table that we required when we were developing it at Walmart. So Hapi brings with it, you know, a really nice routing table and nice plugin architecture. And so just because we're embracing Hapi, we are also having to embrace the plugin architecture. So all of our different web consoles are essentially different Hapi plugins that we can then compose together into a nice server at the end, which it makes it easy with the plugins because you're able to separate your concerns out and really unit test each of those plugins individually and get each of them up to hopefully 100% code coverage, and just focus on the problems that you're trying to solve in just that one plugin and not have to worry about everything else that's on the server until you're actually deploying it and testing it there.
Absolutely, absolutely. And the team that built Happy, that was open sourced by Walmart. But the team, even as people have gone elsewhere, the team seems to still stay strong, and it's got a lot of community development.
Yep. Yeah, there's been a pretty good adoption of Happy. I think a lot of it has to do with, well, we had a lot of support from Walmart to go out and evangelize and spread the good word of Happy. Another part is just the licensing around it. It's just a BSD3 license, and so it's easy for companies to bring it in and try it out.
Yeah. Yeah. David, as you joined the project and got involved, I think you had an opportunity to see things after they'd started to come together. How did you as you started to dig in, what did you learn? What are some points that you can identify that you think we should know about and be thinking about in terms of how this project has worked out?
Yeah. So I'm fairly new to the team, but what I've discovered so far is, I've used Happy in the past, but this is my first opportunity to use Happy 17. So really excited about the, as Wyatt already mentioned, the use of async and await and modern JavaScript features without having to transpile your JavaScript. So I'm real glad to see that. Some things that I've been focused on is around adding more test coverage to some of our modules. And of course, the Happy ecosystem has a lot of plugins that support that to make that a whole lot easier. I think Wyatt had something to do with some of those test coverage tools. And then I think Colin on the team has written about half of the NPM packages that are out there. So we leverage a lot of his tools in building our services. And one of the projects in particular is using GraphQL, and this has been a really exciting opportunity for me to dive into that technology and learn more about it. I think people have heard about GraphQL, but for the most part, people that I've talked to don't understand what it is and what it does.
Well, that sounds like a great opportunity to say a little bit more. You want to keep going?
Yeah, let's just segue right into that. So GraphQL is kind of an alternative to a REST-based API. So we've been exposing a lot of our APIs for this particular web application using GraphQL. And GraphQL is a query language in one sense, that instead of hitting an API endpoint and always getting the same structure of data back, you can query an endpoint and specify which fields and other types of filters so that as a client or a consumer of an API, you can get back only the data that you care about, and you can even do some simple transforms and, meaning that you can get that data in the shape that you want or filtered in a way that you want, so that there's both less data across the wire and less round trips, so you can get more data that you care about all in one trip.
Wow, that certainly has me wanting to look into GraphQL a little bit more. I want to actually bring it over to Colin, who has had a huge amount of huge amount of time working on postmortem debugging and actually just debugging in JavaScript in general. I'd love to press you, Colin, about how that has changed, especially over time, and the ways that you're approaching that problem now to build reliable and debuggable applications.
Sure. So one issue that I guess we should get out of the way right off the bat is that we're working with async and await, and that is built on top of promises. Promises do present challenges as far as postmortem debugging. Their nature of swallowing errors and actually deferring crash until a later point means that you can sometimes lose some of the error state when your application crashes. So you can still work with core files, you can still get useful information out of them, but as of this point in time, it's not a completely solved problem of core files with promises. But it's not like promises, or it's not like core file debugging is the only option out there. So I mean, we're doing things like logging, alerting, collecting metrics, things like that. One thing we lean on heavily that we got from the Hapi ecosystem is 100% code coverage. So, if you can try to reduce your bugs in the first place, there's less to go in and try to debug later. Then another.
I want to pause and I know that's something that Wyatt has been pretty proud of, I think, and not just Wyatt alone, but in terms of that coverage, the test coverage across Hapi and all of our projects, hitting that 100% is something certainly to remark on. Can I ask you to say more about why that's not just good hygiene and why it's helped to really improve the quality of the product?
So obviously there's the issue of catching bugs, but also it helps a ton down the road whenever you need to come in and add a new feature or move code around. The nature of JavaScript is if a line's not being tested, you really don't know if it works. It's because we don't have compilers and things of that nature to catch things ahead of time. So it really helps if you're coming in and trying to rewrite an entire server in Express in Hapi. You can kind of see that it still passes all the same checks and that your code is still behaving the way you thought it would be. So to me, that's an even bigger thing about code coverage than the tests themselves.
Yeah. I'd like to add to that too, Colin, if I may. One thing I
was going to say.
Yeah,
I was going to say this really pushes this. It sounded like Colin just pushed a lot of responsibility onto you, Lloyd, to make sure that we're logging things and doing that work, to logging, monitoring, and doing all the other work to be sure that we can manage and assure the quality of this application while it's running. So take it away from there.
Yeah, definitely. I mean, the more information you have, especially when it comes to logging, the more information you have about your system, the more you can make smarter decisions about things like, hey, what's taking a while? Like you can find response times and how long your event loop is taking and what kind of calls are leading up to that, so on and so forth. You can start making some intelligent decisions about how to optimize and make your things better. Another thing, actually that wasn't mentioned that I've found as a big value of 100% code coverage is all the things that were mentioned previously. But as you get to an actual 100%, you kind of get towards the end, and sometimes you're like, well, hey, I'm going through these functions and I can't figure out how to make a test for this thing, and it kind of leads you to like, oh wait, this case will never happen, and so you actually end up cleaning some of these unused code out because you realize that that's a scenario that you cannot possibly test for, or you decide that, oh yeah, this is way overcomplicated and I need to refactor my stuff to make it easier to read, or split it out into another module. So I think it kind of gives you it kind of helps you along to kind of make better code to begin with, but you have to kind of get to the full 100%, because if you ignore the last hard 5 or 10%, then that becomes problematic.
So I think what we actually dug into Hapi, and that's and learned a lot about how that is really at the center of this. We've learned about GraphQL. Give us the whole picture. I'd love to, from front to back, what do we have in this app that we should be talking about? Why can you start from the front end?
Sure, I can give you an overview of the application, and if I'm missing anything, you all can fill in for me. So essentially, we have a set of different web consoles, and we have them talking to different backend APIs, which are controlling provisioning instances, doing account lookup and management, and just other other services that you would need inside of a cloud. And so we have our wrapper around that, which is exposing a GraphQL schema that then is consumed by a client. And I think a nice thing about GraphQL that we haven't really hit on is the client has to be explicit in what they're requesting. And that's nice just from a simple like validation standpoint. Like, oh, I can validate that what I got back is a string, or this is a number and it meets these constraints. But it also means that down the road, we're able to actually like tear out a feature that's not getting used, because we can see, you know, what the usage is from the client's perspective. And I think this is a shortcoming of REST in general, because you're usually sending back a full record, even though that record may not all be used by the client. And this is something that I've ran into in the past, where, you know, you have all these different client teams and you're wanting to scrap this one feature because maybe it's really putting a drain on your system, but you don't know if anybody's even using it. So you can't. You have to create a new version and try to get people to jump to this new version that's more efficient. So that's something that I really like about GraphQL. So yeah, we have GraphQL API here getting consumed by a React client, and then everything is wrapped up. Each of the web consoles is wrapped up inside of a Docker container, and they're all fronted by nginx. And so nginx just routes to these different web consoles with these various APIs. And the nice thing about having them separate is that we're able to, I guess if there is a memory leak, we can hopefully narrow it down to these, you know, this very specific web console has this issue, and it's not going to hurt the remaining web consoles. You know, they're isolated in some ways. But yeah, what did I miss, y'all?
React.
You said React once.
Okay.
Did it once.
Did you drop?
I actually thought you were going to start there. Actually, Wyatt, I thought you were going to start with React and then go towards the server from there. But yeah. That was a good answer. And wow, the love for GraphQL is really coming out here. Yeah. So actually, what was that?
I said it's just the new thing, so we're excited about it.
That's cool. Actually, so yeah, I'd love to dig in more about that architecture you talked about, Wyatt. So React on the front end, going to the hapi and GraphQL layer via nginx, served from a number of Docker containers. Lloyd, can you talk about it from that side? There's a separate Docker container for each console. How does that, tell us more about that and help talk about what advantages that gives us.
Sure. One big advantage that we do with, you know, kind of making these hapi consoles is that we make Docker images, and we do usually a couple different type of Docker images. One is when we're doing development, it's all based off of our master branch, which is very common in GitHub. So we kind of, when we do commit code, we can deploy and then we tag Docker images and we put a master tag on that. So when we're deploying, we can specify when we're doing our Docker images, which tag we want to use. And we typically default to latest, and latest is kind of like our release. And how we figure that out is we use, when we version things like 1.0.0, and we check for a V tag, and if so, then we say, this looks good, does it pass the test? Publish your actual version and overwrite what the latest is. And it also does that specific version as well. So if you want to roll back, you can do that version. And similarly with master, except master just continually gets overwritten because it's development. So basically understanding all that, to actually get that, we just pull down Docker images, right? And we just use Docker Compose. Now we could go like a little crazy and do Kubernetes and all that kind of thing. But in our particular case, as engineers, we tend to spend a lot of time over engineering sometimes just because it's cool. But in our case, we just wanted it nice and simple and clean. And so we're using just Docker Compose right now because that meets our needs. And so it does kind of the nginx and we kind of have it all in one. And again, what was kind of mentioned a little bit before with the Hapi plugins is that should we have a need to increase its complexity, let's say one of our particular consoles is very intensive and we don't want to just host it on one server, we can certainly split that out just like any other Hapi plugin and handle that architecture with pretty good ease. And that's kind of the big advantage of Hapi plugins. So it's kind of like a one-to-one equivalence with Docker and our plugins. And then
right. So
go ahead.
So each console is a separate Docker image, and that adds a lot of flexibility to independently deploy updates without affecting. Well, actually, let's talk more about that one. And I'll throw this one up in the air. During that development workflow, how do you? We talked about testing, the great test coverage, and we have this understanding now that each console is basically a separate Docker image, a separate artifact. What's the confidence? What is it about the structure that gives us confidence that we can move forward with changes to one console such that they won't affect behavior of another console, or do we have even that confidence?
I think that just comes down to the more and more testing that you have, the more confidence you gain in your system, right? And it's kind of one of those a very common idea, common theme is continuous deployment. And essentially you want to build something that you can always do a continuous deployment if you want to. And as your product matures, you get more tests in, you can kind of do integration testing, all of those kind of things gives you more and more confidence that you can do that. And then, again, if you have a very simple app, you get to that stage quicker. If you have a very complex app, you may never get there, right? So it just depends.
So architecturally, have we put in some firewall? I don't want to use the word firewalls, but have we put in some bumpers to protect ourselves so that we can move quickly in one console without worrying about affecting another console in this architecture by building each of the consoles as a separate Hapi plugin and then deploying it as a separate Docker container? Do we have some bumpers to allow us to move quickly without running over our own feet?
Yeah, exactly. And so if you have kind of these separate containers in each one, you can, right now we kind of deploy it more ad hoc. So it's kind of done for everything, but there's nothing preventing us to say like, oh, I want to just push this one console out, right? Because it's all kind of contained within URLs. So there's nothing preventing us from having that flexibility. And that's, I think a lot of companies struggle with that, where, they kind of start out, they have kind of like bring everything down, bring everything up. And they really want to get to that stage where, hey, I have just this one little service, or, I just have like this HTML content that needs to go out, right? I don't want to take down my whole system. I just want to push out those changes. So definitely this allows for those kind of flexibilities.
Yeah. All right.
I think it's also worth noting that all of these images are all open source. So we're using Dockerhub to host everything. And yeah, it's all open source.
And so, so what I'm hearing is that there's a lot of simplicity to the workflow around a lot of convenience around the workflow that's been built. Can you tell me more about how we handle secrets, various keys, and other details that are necessary and generally can't be shared? How do we handle those? Are those baked into the image, or are they injected at any time? Want to say more about that?
I'll let you take that one, Wyatt.
Yeah, so we try to bring everything in that is a secret as an environment variable. This also means that if a secret is in a change, we're going to have to redo that container. But the nice thing is we're able to keep using Dockerhub and the Docker registry, and we don't have to host our own, even though that wouldn't be a problem. The main concern, I think, is that we're an open source company, and we want to make sure that what we're building is out in the open for anybody to try on their own, and maybe even one day contribute back if they're so nice to do.
You know, I want to turn that around, because I think you're making a great point. But one of the things that you may be talking about is how being open has improved your approach to solving some of these problems. Things that we might have been lazy about, and it's those little bits of laziness that can accumulate over time to cause a big mountain of debt. It sounds like you're arguing that by being open and assuming that these images are going to be public images all along, there's some better practices and good practices that are coming from that. Is that true?
Yeah, I mean, I definitely think that any of the code that I'm doing that's open source, I'm probably more likely to, because other people are out there judging me, I want to make sure that I have better code coverage, that I'm not leaking secrets, and I'm just more cautious, I think, than any private code.
All right. What about around the room? Colin or David, any thoughts about that particular issue?
I would definitely echo what Wyatt said. So any substantial open source work is always going to be better than its closed source alternative, because you kind of have to take these steps to make sure you're not getting hacked. If we bake these secrets into our Docker images and put them out there in the open, who knows what could happen. But completely agree with what Wyatt said.
Yeah, and having the fact that things are open source, it's kind of like what Wyatt said, is incentive for you to do maybe up your game a little bit. And it's great that we have some coding practices in place, like peer reviews and whatnot, where we not only can ensure code quality, but we're not making dumb mistakes, and we're not putting out subpar quality code, and they can continue to reject all my pull requests because I may fail to to do something the right way. But yeah, I think it really helps to improve our code quality overall.
Yeah. David, can I ask you to walk me through, just because you were mentioning it, can you walk me through how it changed when you're working on something? And I know that recently you were adding a lot of extra test coverage to get us to the 100%. Can you walk us through how that change makes it through the process and the workflow for which that eventually gets us to? Actually, the test coverage is maybe a bad example, but a change elsewhere in the product, something that a user might see, how the workflow to get that out.
Yeah, so I mean, we've got a fairly simplistic workflow, which is great. I mean, there's not a whole lot of friction to building and releasing new features for all of our tools and services. So in essence, all our projects are open source, and we can create our own fork of that code, make some changes, push it to our fork, and then create a pull request from our repo to the upstream repo. Some of our repos require review, so you can't just go and willy-nilly merge a bunch of stuff in by yourself. You have to have other peers in your team to review that code and approve them. And then in some cases, those are like, if they're plugins, then we can publish those to NPM for other projects to then pull in those updates, or other teams that can take advantage of those.
Cool. And I think so. There's a code review. I'm tempted to ask who among the group is the harshest reviewer, but I imagine the answer is that yourself. Each person is his or own harshest reviewer. But actually, Lloyd, can you walk us through, like, once that pull request is merged, then what happens on your side?
So yeah, when the the pull request is merged. We actually do that in Travis, right? Because it's all open source and we just leverage that. So what happens there is once that's been merged, depending on if it's tagged or just in master, it will, there's basically a puller and Jenkins will take that and it will again double check those tests just to be sure. And then from there, make a Docker image. So it's doing kind of your basic Docker build type commands. And then after that's done and successful, we particularly when we do versions, we actually use NSP to do like a nice security check to make sure there aren't any vulnerabilities before we actually make this live. And if all that passes, then we actually will do a Docker push. And then those images are out there to freely download. And then we pick a data center that we've deemed as kind of your staging or testing or whatever, and we deploy that, and then we test it and we run test cases against it, and again, if that all looks good, then we ship it, right? That we just go to each data center and say this is the versions that we want, typically just the latest. We may go back right in the process to do like, oh, this looks good in master, let's tag it, and so let's test it, kind of go read through that process. Now I'm going to deploy the latest of everything. That looks good. And now let's just put it into all the data centers.
Awesome. Awesome. I've been focusing a lot on the operational bits here. Who wants to take us deeper into things that are done inside the application that we should be thinking about? Colin, do you want to dive into that?
Metrics.
I can try. So the majority of the heavy lifting is happening on the front end, and then an upstream service that we call into Triton's Cloud API. In our layer, we're doing a lot of basically sanity checking things. So, making sure we're getting good metrics out, making sure that response times are in the area where they should be, just making sure that the application seems healthy. And then also if things start going bad upstream, or if we're noticing issues in other places, it's important for us to be able to recognize those and alert the right people. And Lloyd and myself have actually been doing some cool work recently with nightmare.js to try to, it's like a front end automation module for Node. So it's a headless browser basically, and we can click through the site, make sure that every minute or two that not only are we getting a healthy like uptime, you ping /health and get okay back, but with this approach you can actually go to the site, log in, make sure that you can provision an instance, then tear that instance back down and report that as a healthy uptime. So Lloyd's been doing some work around integrating that into our automation, and hopefully he's going to be able to start putting together movies from the nightmare scripts.
Yeah, like it makes basically at any given stage, you can take like a PNG screenshot with it. And so I'm hoping to use a tool like FFmpeg or something like that just to kind of smash them all together. And then save it as an artifact. And then we can actually see it. It won't be quite like a movie, but it'll be a collection of images. So probably more like a slideshow. But if we have a problem, we could kind of see what's happening with that artifact.
Awesome. All right. So one of the things that was really important, and some of the reasons that we had to replace, to actually take on this big project to replace this existing application, was how difficult it had been to identify and fix bugs, so improving our velocity for bug fixes, but also our velocity for feature additions. But one of the most difficult things that we faced was digging into how the heck we were going to improve performance. And as we dug into that one, it became increasingly clear that was a reason to be looking at a full rewrite. I want to ask around the group: are there things that we had a chance to add or look at as we were doing that because of this opportunity that have helped either the performance or the debuggability? Wyatt, perhaps you have some ideas?
Yeah, so one of the things, just given a greenfield project, it's really nice it's just a nice opportunity to start integrating these new technologies. So one of them that we've been talking about is GraphQL. Another one is OpenTracing. So OpenTracing is a nice way to look at distributed systems and just see where your actions or your events are actually being spent, where your time is being spent. And since we're sitting between this client that we're trying to be an advocate for and all of these other distributed systems that may be misbehaving, we need to be that advocate for the client and make sure that we're spending our time wisely, and then these other services are responding in a reasonable amount of time. So we've added OpenTracing into our web consoles, and this has actually helped us fix a couple of little bugs from the front end where they're actually making more requests or requesting more data than they needed. It's also helped us just pinpoint where we're spending our time with downstream or upstream systems. Has anybody else found OpenTracing useful so far? I feel like it's going to pay off in the long run as we keep adding in new upstream services.
I think it's going to help too when we finally gather all the metrics and start really seeing like a dashboard of it more cumulatively versus just on a particular instance. I think that's going to where it's going to really pay off.
I think the OpenTracing stuff is going to be one of those things where normally we don't need it, but once we do need it, we're going to be really glad that it's there.
Mm-hmm.
Yeah, actually, Colin, I want to press Colin and Lloyd both. I want to press the relationship perhaps between OpenTracing and the points you were making, Colin, about about some of the challenges to debugging, and it feels like this is really a system-wide view of debugging, where the systems are made up of multiple independent components that are interacting with each other in ways that can be hard to identify clearly through a single core file. Am I talking about that in terms that make sense, or am I full of it?
No, that's right. So I think that approach started with Google's Dapper, kind of passing request identifiers through a service. It really helps when you have distributed services or microservice-based architecture, which is kind of what we're implementing here. Because without that, then you kind of run the risk of, the client makes a request to your upstream, and then that can balloon into, multiple different requests, and you really don't know how all the different requests going through all the different services correlate with one another. So by using some tracing, it can actually help you kind of streamline that.
Awesome. So as we've been talking, I've been taking notes about the things that have gotten all of you excited. Obviously, OpenTracing there. We learned from Wyatt about Happy and others. I think everybody has sung the praises of GraphQL, and I was excited to learn about nightmare.js. These are things that we've dug into or that you've dug into as you've had a chance to build this application. Any last words about what you're hoping to do next? What you think is the next step that you're excited for?
More understanding of the metrics. That's what I'm excited about, kind of doing like dashboards and seeing how things like, loops are going and how many requests we're getting per second. When you have if you're looking at log files, there's just too many logs to kind of parse through all that. And I'm really excited to be able to see how our things are performing, how our downstream services are performing, those kind of activities. That's kind of what's next for me.
Cool.
For me, it's enhancing GraphQL. So one thing that we need to solve is the GraphQL subscription support over WebSockets. So that's something that we'll be working on. Also, some of the validation that's supported with GraphQL is pretty basic. It's just basic types. So I'm working on enhancing that to be more aligned with Joy, which is our validation framework in Hapi, so that you can actually say, this needs to be an email, this needs to be a username between this length and that length. So yeah, just enhancing GraphQL to meet our needs and helping hopefully support the GraphQL community.
Cool. Yeah.
For me, I'm personally working on getting Lloyd that data he needs about metrics. So right now we're exposing a lot of Node process level metrics in a JSON format. I'm working on getting kind of higher level statistics such as request rates, response codes, things like that at the HTTP layer, and working on exporting all of that as Prometheus.
Cool.
I don't really have anything. I look forward to being awesome and eating bacon.
Yes.
All right. Well, I want to thank everybody for joining us. Colin, David, Lloyd, and Wyatt, all of you. This has been a fantastic opportunity to talk and learn more about the applications that the web consoles and the work that you've been doing. And I look forward to learning more and when we catch up again. Yeah, so no, really, I'm really excited that we're able to learn all of this about it. There are going to be links in the post to some of the things that we've mentioned, and of course, take a look at some of our other product offerings, especially our Node support offering. Thank you all for joining me today, and I look forward to seeing everybody again in another Fireside Chat.
Bye.
Bye.